The global astronomical community is on high alert following the unexpected return of the interstellar visitor 3I/Atlas. What should have been a simple re-observation after its passage behind the Sun has transformed into one of the most intriguing phenomena in modern astrophysics. Dramatic changes in trajectory, anomalous brightness variations, and spectral alterations are challenging conventional explanations and raising questions that go far beyond what we know about interstellar comets. When 3I/Atlas temporarily disappeared from the observation line as it passed behind the Sun, few expected that its return would cause such a commotion in the scientific community. Unlike previous interstellar visitors such as Oumuamua and Borisov, this object was being tracked with cutting-edge technology by multiple observatories around the world. The passage behind our star is a common and predictable astronomical event. For several weeks, the intense solar brightness prevents direct observation of objects transiting through that region. Astronomers had meticulously calculated 3I/Atlas's trajectory, establishing precise windows for when the interstellar comet should reappear on the other side. All predictions pointed to a visual re-entry without surprises. Computer models, fed by months of previous data, indicated where and when the object should emerge again. But what happened upon reappearance surprised the entire scientific community in a way that few cosmic phenomena have managed to do in recent years. The first measurements after reappearance revealed something extraordinary. 3I/Atlas's trajectory had undergone abrupt changes that could not be explained solely by the Sun's gravitational influence. The detected deviation was beyond the margin of error of the most refined orbital calculations, suggesting that something significant had occurred during the period when the object was obscured. Even more disturbing was the brightness behavior. The luminous spectrum of 3I/Atlas varied anomalously, presenting intensity peaks and abrupt drops incompatible with the expected pattern for a common comet. It was as if something had occurred during the solar eclipse, some event capable of fundamentally altering the object's reflective or emissive properties. The most sensitive equipment detected significant alterations in the spectrum of light reflected and emitted by the interstellar visitor. These spectral changes are particularly intriguing because they indicate possible transformation in the nucleus structure, something that shouldn't happen so dramatically in such a short period. The apparent chemical composition of the object seems to have modified, raising questions about unknown physical or chemical processes. Data collected in the infrared range brought even more puzzling evidence. Thermal readings suggest that part of the comet was heated beyond expectations, even considering its proximity to the Sun. The recorded temperatures significantly exceed theoretical models for solar heating of objects with 3I/Atlas's presumed composition. Two main hypotheses emerge from the initial data. The first involves the possibility of impact with solar material ejected during an undetected radiation storm or an unknown electromagnetic interaction with the solar magnetic field. Both explanations, however, face difficulties in explaining the magnitude of the observed changes. The second line of investigation is even more intriguing. Some astronomers are beginning to consider an internal reaction within the object itself, as if some latent process had been activated by intense radiation or by the extreme environment near the Sun. This possibility raises fundamental questions about the nature and composition of interstellar visitors, suggesting they may be far more complex than we imagined. The official response from major space agencies has been cautious, almost evasive. Both NASA and ESA confirm 3I/Atlas's reappearance and acknowledge that new observations are being conducted, but avoid deeper interpretations about the detected anomalies. This institutional silence contrasts with the effervescence of discussions in scientific forums and academic networks. Even more concerning are reports coming from independent research centers. Several of these groups have reported inconsistencies between the public data made available by the major agencies and their own measurements. Some researchers with access to private or university telescopes claim to be detecting characteristics of the object that don't appear in official reports. The international scientific community is intensifying calls for greater transparency. Astronomers from different countries argue that we are potentially facing an unprecedented event, and that open collaboration is essential to understanding the phenomenon. The debate about access to raw data and analysis methodologies has become as intense as discussions about the nature of the object itself. Among defenders of natural explanations, three main scenarios are being debated. The first involves a massive ejection of material from the comet's nucleus, possibly triggered by extreme solar heating, which could explain both the trajectory change and brightness variations. The second proposes a partial fragmentation of the object, with pieces separating and altering its orbital dynamics. The third suggests a form of extreme solar interference not yet fully understood, involving complex interactions between the solar magnetic field and the interstellar visitor's composition. However, a growing group of scientists is exploring bolder hypotheses. Some researchers question whether the observed movement could indicate some form of control or active response from the object, although they are extremely cautious in their public statements. Others are investigating whether intense solar radiation could have triggered some type of reaction in unknown elements or compounds in the comet structure. The most controversial discussion involves the possibility of technological presence. Inspired by the Oumuamua case, some scientists don't completely rule out that 3I/Atlas could be or contain something beyond ice and rock. This line of thinking remains marginal, but the observed anomalies keep the door open for fundamental questions. Is it just a comet, or something more? The very nature of the question reflects how extraordinary the observed behavior is. The global astronomical community's response has been swift and coordinated. Observatories on different continents are preparing massive campaigns to track 3I/Atlas continuously in the coming weeks and months. Space telescopes like the James Webb and cutting-edge ground-based telescopes are directing precious observation time toward this mysterious visitor. The focus now is on collecting data from multiple wavelengths simultaneously, creating a complete and continuous profile of the object's behavior. Special attention is being paid to any additional changes in trajectory, brightness variations, spectral alterations, and possible unusual emissions. Each new observation may reveal whether the object is disintegrating naturally or exhibiting some type of reactive behavior. The next phase of investigation will be crucial. If the anomalies persist or intensify, we'll be facing a phenomenon that challenges our current understanding of interstellar objects. If, on the other hand, the behavior begins to normalize, it may indicate that we witnessed a rare transient event, but still within the limits of known physics. One certainty remains. If 3I/Atlas changed behind the Sun, perhaps what returned is no longer the same object that disappeared. Whatever the final explanation, this visitor from the depths of space has already secured its place as one of the most intriguing astronomical phenomena of the 21st century, reminding us that the universe still holds mysteries capable of challenging even our most sophisticated scientific models.